Hello everyone, I hope you are doing well. In this video, I'm going to show you some examples from C++20 and C++23 features. These are really amazing features and it's going to be surprise you, and you might say by yourself, oh my goodness, C++ has these kind of features, or you might have already seen them. But these features was really interesting for me. That's why I've decided to share with you. This video includes multiple features from C++20 and 23, and each slide will going to start something like that. Each slide starts with a sentence like, did you know, for example, about this feature in C++20 or C++23? And then in each slide, we also have an example that is implemented in C++20 or 23. You will see a lot of examples in this video, and the examples are self-explanatory. And also in each slide, there will be a link. This is the Godbolt link. The examples also implemented in Godbolt's online compiler. You can also use that link and see the real implementation. Okay, let's get started. Did you know that C++23 added a stack trace library? You might have already seen this feature in JavaScript or Python language, and this is an amazing feature. Here we have the main function, and inside main function another function is called foo, and inside foo function the current function is called from standard stack trace library, and here the output, the stack trace is printed out. Now this amazing feature is available in C++23, and that's really great. Did you know that lambda expression is guaranteed to have a unique type? In C++, the compiler guarantees each lambda expression have a unique type. For example, if we create a lambda expression at this point and we get a type ID, the type ID won't be equal to another lambda expression. These two lambda expressions have different type ID. Let's see another interesting example. Here we have a template structure, templatized structure, and the template argument is that a lambda expression type. It means each object from this structure that will be instantiated will have different type ID. Let's see the rest of the example. Here, two object has instantiated from foo class, and if we compare the type ID, they will have different type IDs. These are also interesting. Let's see another one. Did you know you can pass an array by reference in C++? Let's see that. Here we have four functions. All of the four functions receive an array as the input. The first one receive a pointer, integer pointer. The second one receive an array type, but it has a fixed size. The third one receive an array as well, but it doesn't have fixed size. The last one is receiving a reference to an array. Interesting. I've never seen that. Okay, and in main function, we have created an array. It has a fixed size, 42, and we have called all of those functions. All of them are run and compiled successfully. Okay, the next one. Did you know that Circle supports Python's extended slice syntax for variadic packs? Before getting into the example, let me explain what the circle is in C++. You might already know in C++20 there will be a new language which are called concept. Concept will be a replacement for meta programming, template meta programming, and also template feature that we have already in C++ 11. And there will be a lot of tools and libraries for these concepts. One of them will be about meta circle library that has introduced it in C++ 23, and it will be a lot of feature. You will see some of them in this video, but here this is an interesting feature in that library. We have foo function here. This is this function argument, input argument, and output argument will be deduced automatically. I mean, their type will be deduced automatically. It's same as a template function. And also the input argument is a variadic pax. And here inside the function we can access to the variadic pax by index operator. This is really amazing. You see, for example, at this point we have access to the first element of variadic pax. In the next line we have access to the first two elements by this operator. It's same as a Python or MATLAB. You might have already seen them. In this line we can access to the every second element by this operator. And the last one, you can also let's say iterate in reverse to the variadic pax. And in this example, if we pass a negative index, it will iterate in reverse. That's why if we pass -1, it prints the last element in the pax. Amazing. Did you know that C++ 23 allows extended init statement with alias declaration in the for loop? I really love this feature. Look at that. In the main function we have a range for loop, but this is a little bit different because it uses concept. At first we use we declare a concept t, it uses int concept, and then we declare the iterator, and this variable will iterate on this container. Every time in the loop the e assigned to 1 and to each element of the container. Okay, it's so simple. It's not surprising, but look at this one. Here we have a structure in the initialization part of range for loop, and this type includes two fields. This is a structure, it has two fields, integer x and integer y. Okay, and here this is the iteration part. We have declared an iterator, and iterator will iterate on this complicated, not complicated, a little bit complex container. Each element of this container is an t. It's from t type, and every time this iterator will be assigned to one of them. This is really amazing in C++. I can't wait for it. Did you know about C++ 23 ispanstream? This is a strstream replacement using a span as buffer. Yeah, we already had a strstream library in C++ 11, but a strstream uses a string as underlying buffer. And you know that a string gets memory. It's not that much light, but in C++ 20 we have range and we have span and we have views. There are let's say lighter containers that is introduced in C++ 20, and in C++ 23 we will have ispanstream. This is a stream for a span. Okay, we have declared an array of char in the first line, and then we have created an span from this buffer. This span object is really light. It just includes 2 pointers that refers to the first of the string and the last of a string. And here we have a stream that it's really light. It doesn't consume that much memory because the underlying buffer is an span, refers to the span, and the span refers to the string. Amazing. Did you know that C++23 added ranges to function? This is a conversion function from ranges to containers. Yeah, ranges and views are amazing features that is introduced in C++20. But we can also convert them to the real containers. Here we have an example. We passed a view to this function ranges2 by a pipe operator, and it converts the view to a container, to a std vector. Alright, this is really an amazing feature in C++. I really like this feature. You know that in C++ we can make mathematical expressions very easily. For example, we can say 2 divide by 1, and then C++ is able, C++ can compile it and then run it and generate the result for you. But we can generate these mathematical expressions or other C++ expressions in a more easy way. Or sorry, it's not easy, or in the other way. Here we have bind front and bind back functions that we can make C++ expressions in the other way. Let's say I want to say I have a number 1, and I want to put a mathematical expression in front of 1. I want to say 2 divides, this is an expression, in front of 1. Okay, then it will be a mathematical expression. The result will be 2. I can use this function and say, okay, I have a binary operator, divides, and then I have 2. This will be an expression like 2 divide, and I want to put this expression in front of 1, and then generate the result. Okay, we can also put an expression in the back of a number or variable. For example, I want to say 1 divides by 2. Here, this is my expression, divides by 2, and then I will put this expression in the back of 1, and I will have 1 divides by 2. It will generate 0.5. This is really an amazing feature. I would say that I don't know where this functionality will be useful for us, but I think if we are going to implement a kind of interpreter through C++, this kind of function might gonna help us, but I'm not sure about it. Did you know about C++23 proposal? A structured binding can introduce a pack. I would love also this feature. You might have already seen a structured binding in C++17, but this is a more interesting feature. Here we have a tuple. It includes 3 values, 1, 2, 3, and here we use a structured binding, but we have passed just 2 variables inside the structured binding. We have first and then another variable. The first element will be set to this, let's say, variable, but the rest of variable, I mean 2 and 3, will be passed to the TS, and TS will be a kind of container. That's really great. Did you know that C++20 added these functions, all of, any of, and none of, to the standard ranges algorithm? Yeah, we already seen these algorithms in C++11 for the standard containers, but you know that in C++20 we have range and we have views. Now these functionalities are available for ranges as well. For example, we have in the first line we have all of, and then we passed let's say a container. This is an array, and in the second argument we have passed a lambda expression. This is an applier function for all of, and it says if all of values are equal with 1, then this function will return true. Okay, did you know that C++23 added std to underline? This is also an amazing feature, I would say. Here we have an enum, and enum has just one constant. The constant name is QL, and the value is 42. You might have tested before this one. If you want to access to the type ID of this constant, it's impossible. For example, if you say type ID and then pass the QL constant to the type ID, it won't be compiled. But in C++23, you can have access to the underlying type information of a constant, specifically for the enum. For example, you can say you can pass the constant to this function, to underlying, and then you have access to the underlying type of this constant, and then it will be possible to get a type ID of this constant. This is also really great. Did you know that C++20 added a standard erase if for map and vector container? Yeah, this is also interesting. We have a vector. Vector includes 1, 2, 3, 4 numbers. Okay, the size of vector is 4. We can call erase if, and then pass vector as the first argument, and then this is the function, the applier function, and in the applier function we want to remove the even numbers from the containers. And in the next line, if we get the size of the vector, we will have 2. Did you know that C++23 added standard unreachable? It's really weird in this functionality. I don't know why do we need these functions, but here you see if we call this function, when the execution flow reaches to this function, not execution flow, wherever the compiler sees this function, the rest of the codes won't be compiled and added to the binary. I would say, I'm not sure about the functionality, but here in this function, because we have called this function at this point, it will cause an undefined behavior. I don't know about the requirement of this function, why they've added this function to the standard library. Did you know wrapping an unqualified function name in parentheses suppressed argument dependent lookup? Okay, it's also interesting. If you don't know about argument dependent lookup, this is an example. Here we have a namespace called ADL. It includes a structure and also a function. If we want to access to the structure or any object inside the ADL namespace, we have to use ADL namespace. We have to say ADL then the namespace operator, and then we can access to the structure or the function. We know about this signature, but the second line is a little bit weird, because you might say why we haven't used the ADL namespace in front of bar function and how it will compile. Yeah, it's compiled because in C++ we have a feature called argument dependent lookup. Because the foo type was in the namespace ADL, that's why the compiler tries to find the function bar in that namespace. If it finds, it will be okay. It won't throw any error or compilation error. But if we want to suppress this feature, I mean argument dependent lookup, we just need to pass the function name inside a parenthesis. Did you know that C++23 added std byte swap to swap bytes? This is also interesting. Here in the first line, we have declared a variable. It's a hexadecimal value. It includes an hexadecimal value. And we can also print it out. If we print it, it will print this one, CAFE. It includes 2 bytes. CA is a byte, FE is another byte. Byte swap can swap a 2-byte variables. For example, it swap the first byte with the second byte. If we call the byte swap and pass the value to it, it will turn it will return this one. You see, at this point, the first byte is swapped by the second byte. Did you know that C++23 added Monadic operations for standard optional? If you are interested in functional programming, that feature will be for you. You might already know in C++17 we had futures, not C++17, I think we had it in C++11. We had futures, future class, we had promises, and they also had monadic operators. For example, future had a then function. If I'm not mistaken, I'm not sure about it. I have a doubt about it. But I know the future and promises was sort of objects that brought functional programming to the C++. But here, these monadic operators are available for optional. For example, here we have created an optional. It includes 42. It has value, and we can say we can use and then function, and we can pass a lambda expression. If this optional variable has value, then this function will be run. I guess I've seen this feature in Java, if I'm not mistaken, but now it's available in C++. Did you know that C++23 added std move only function? Yeah, we know that in C++ we have function class, and this is a function object. We can create function object, and you know that this type is movable and also copyable. For example, we can copy this object. It's okay. We can also move it, but in C++23 we have a new type called move only function. This type will be just movable. We can't copy that. If we try to copy, it will generate a compilation error. Did you know that C++23 added resize and overwrite function to the standard string? This function is a little bit interesting. Okay, here we have a resize and overwrite function. It receives a string as the first argument and the size of the string as the second argument, and then we get the size at this point, and then we call this function resize and override on the string. The first argument is the new size. It will resize the string to this new size, and then the second function is the override function. It resizes the a string buffer, and then it overrides the buffer through this function. Yeah, it's also interesting. Did you know that C++20 added type identity, which implements the identity metafunction? Okay, what is that? Here we have two print functions, and both of them are template function. They receive a template type, and in the first function we just print out the type ID name of the template type, the template argument. But in the second one, we get at first we get the type identity of template argument, and we pass it to the type ID, and then we get the name. Okay, let's see what's the difference and what are the results. For example, if we print out the int const reference, the first function, I mean type ID function, will just return the int. But in the second one, it will return int const reference. Okay. Did you know about C++2x proposal to add multidimensional subscript operator? This is also really an interesting feature, because you might have already seen this feature in Python or MATLAB, but here it's available in C++. Here we have a class mdArray. This class has a buffer, and the buffer is an array, and it overrides the index operator, and you can see now index operator is able to receive two arguments. And this is the interesting part. It means we are able to call the index operator like this. We can pass two arguments to the index operator. Awesome. Did you know about compiler predefined macros associated with the compilation date and time? Yeah, in the compiler, there are two predefined processors, time and date. These two preprocessors that refers to the date and time. They can be useful in compilation time. Did you know about different ways of accessing CSL arrays by index? This slide will gonna surprise you. Here we have an array. You have already seen this syntax. We can access to the array elements by index and pass a number. Okay, we know that. But look at this one. This is the amazing part. Did you know that we can access to the index of an array by this syntax? It was really weird for me. Did you know that circle meta model allows to convert a string to a type? This is also an amazing slide. Here, I've given you a kind of basic introduction about circle meta library in C++23. This is another feature from this library. Here we have declared a string, but we put the meta, let's say, operator in front of the declaration, and then but the type is an integer, and then through this string we have declared a variable. Amazing. Did you know about C++2x proposal for the circle meta model for compilation-time metaprogramming? This is also another interesting slide about circle meta model. Here we have main function, and we have two print functions. The first print functions will be run during runtime. When you run the program, this print function print out the hello world. But the second function, this standard function, will run in the compilation time because you have put the meta operator in front of this function. This is amazing. It means we can run a standard library in compilation time. Did you know about built-in dump struct Clang extension which can nicely print a structure? This is just a feature for Clang compilers and environment. You can print out a structure with this feature. For example, here we have a struct trait. It includes two fields, price and size. Then through this function we can print out the this object, and it will print it like this. Did you know that circle meta model allows for applying normal STL for operations on meta types? Actually, this example also really weird for me. I didn't understand this example. If you are interested, you can investigate more about this one, okay? Did you know about C++ 2x pattern matching using is and as operators? This is also an amazing feature. Let's see how it works. Here we have a f function. It receives an argument and the type is deduced automatically. And we have another function inspect, but it's called in a weird way. I can't understand the syntax how it's called, but it is what it is. And it tries to match some patterns regarding this variable, and then if any pattern is matched, it print out a string. And let's see how it works. If we pass an integer to this function, it will say this is an integer 42 because it's matched by the first match expression. If we pass a pair, and pair includes 0 and 2, it will match, let's guess, I think the first. This is also an amazing feature. Did you know about function try block and that exception caught inside that block are implicitly rethrown? I haven't seen these features so far in the C++, but it's available also in C++. I'm really surprised when I've seen this feature for the first time. Let's see the main function. You see, in the main function, the try catch structure is called in a, let's say, in a weird way. You see, immediately after function name, the try has used, and then we have catch, and also we have bar structure here, and inside the bar constructor we use same thing. You see, we have try block, and then we have catch block. This is also amazing. I didn't know that before. Did you know about methods to access the last elements of variadic packs? Variadic packs are really amazing feature in C++. I really do like it, but it's a little complicated for me. But here we have an example that can directly access to the last element of variadic packs. It includes two methods. The first one is here, and the second one, I didn't understand the first one. If you are interested, you can investigate more about it, but the second one is a little bit more interesting. For example, we have called last two, and we have passed two variables, and here through this weird syntax it returns the last one. Amazing. Okay, thank you so much for watching this video. I brought all of these amazing features from this link. It was from CPP tip of the week from QuantLab Financial. It had a lot more tips, but I've tried to just bring those tips that are really more interested for me. You can also look at this link and find more interesting tips of the C++. Thank you so much.